All of the questions I've done for you so far, I've given you the equation. Now I'm going to give you a bunch of information and I want you to figure out the equation. Look at this example. I love this. The Singapore Flyer. That's the world's tallest Ferris wheel. And I found a picture of it on the net. Take a look at this thing. This thing's huge. Every one of these things here is a capsule, so that prevents people from like leaning out and getting injured or anything like that. But they're all in capsules like this, and this thing spins around and around, and you can compare it, even though it's shot at a different angle. Compare this with the height of the building here. This thing is massive. It is incredible. Could you imagine the views? No, I can't, because I hate heights. Oh my goodness. I would never get up there. Never in a million years would you get me up there. Maybe if you paid me. No, 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 not going to happen. But anyways, let's look at this. Let's see if we can figure out a sinusoidal function for this. Now, why? Because it's there. All right. So take a look at the information I've given you. This thing has a diameter of 150 meters. So from here all the way up and down, this is 150 meters diameter. My goodness gracious. And it also tells you that it reaches a maximum height here of 165. So this height right here is 165 meters off the ground. Holy moly, that's incredible. Okay, and it takes 32 minutes for this to go one revolution all the way around. Oh, I'm dizzy just thinking about it. Holy smokes. Okay, so what can we conclude out of this? Well, if this guy's 165, this guy's only 150, that must mean that it's actually 15 meters off the ground. It has to be 15 meters off the ground in order to give you a total height of 165. No kidding, you don't want this Ferris wheel touching the ground. Because if a Ferris wheel touches the ground, it is now called a tire and it will roll away, right? So you want it off the ground a certain amount. Okay, so this is off the ground 15 meters. All right, so my question is this. Let's figure out a few things here. Can we figure out some information? Well, obviously, let's look at this. Let's be smart. Think about this. Let's try to graph this right off the bat. You know and I know it's going to start here at 15 meters. That's going to be this lowest point. You also know that it's going to go up to here, which is 165 meters, which is its highest point. It picks up people down here at a time of 0. It goes all the way to the top, and then comes all the way back down. That's one complete revolution. And that one complete revolution is going to take 32 minutes. Boom, 32 minutes. Oh, interesting. Look what I just made. I just made a sinusoidal graph. Unfortunately, this is not a sine graph, but in fact, it is a cosine graph. Because remember, cosine cup? Yeah, this is cosine upside down cup, which means that we're actually going to deal with a negative cosine function. Yep, we're going to flip it. But look at what we've got here. We've got a maximum height. We've got a minimum height. So now we can find all the values that we want, can't we? All right, let's go out and find all the values that we want then. First things first, let's find the amplitude. The amplitude, remember, small little stick means that it's 165, your maximum, minus 15 over 2. 165 minus 15 over 2, well, you could do that. That works out to be 75 meters, right? Okay, 165 minus 15 is 150 divided by 2, 75 meters. Well, come on, we knew that because from the top to the bottom is 150. That must mean, guess what? The amplitude's got to be 75. That makes total sense in the world. How about our D value? Where is the center of this graph and how far is this off the ground? Well, you got the numbers. Well, 165 plus 15 over 2. 165 plus 15 is 180 over 2 works out to be 90 meters. There's your D value at 90 meters. Wow, that's so far so good, right? Yeah, it's actually pretty easy. Now, here's the other thing that we got to think about. What else is given in this question? Well, what else is given in this question is you're given the period. It takes you for one complete cycle, it takes you a period of 32 minutes for one complete cycle. So guess what? Find me the B value. The B value, of course, is 2 pi because we're always in radians over 32, which you can reduce this if you want to pi over 16. There you go. There's your B value. So now you can write an equation. The equation's really easy. The equation will be, okay, y equals to, since it's reflected, right, since it's flipped, got to be a minus cosine value. This is minus, oh, but wait, what's the A? The A is 75, okay, 75 cos. What's the B value? The B value, oh, pi over 16, we know that. Pi over 16. Did we shift it at all? Did we go left or right here? No, we started at 0 because that's where people get on. And it takes them up to 32 minutes to get there. So this is just plain old x plus the d value. The d value we worked out to be 90. Beautiful. There's our equation for this thing. So, but if you read the question, it says equation h of t. Remember, you have to deal this as an h of t, height as a function of time. So that's easy. Just change everything around. 75 cos. That's pi over 16. This is now time plus 90. Oh, that's easy peasy. Okay, but it also says I don't want this as a negative cosine. I also want this expressed as a positive cosine. Oh, man. But ask yourself a couple questions. Will this wheel at all change? No. It's still got an amplitude of 75. Its d is still 90. Its period is still pi over 16. All of those values are the same. The only thing that changes is the fact you want this to be a positive value, which means you're going from here to here now. But what is this point? Well, it's halfway through your ride. It's the highest point, isn't it? Halfway through the ride is at 16 minutes. Oh, so guess what? You're going to shift this graph to the 16-minute mark. Oh, what does that mean? Real easy. What that means is just this. You're going to go h of t. It's still now not a negative anymore. It's a positive 75 cos. This value is still pi over 16, right? Well, I don't have to put a bracket there. I'm just going to kind of eliminate that. It's still pi over 16. There's my b value. Now, my bracket means I shifted it to the right 16 minutes. So if I'm shifting it to the right, that's minus 16. There's that whole thing plus 90. Now, how are you sure that this is right? Probably the easiest way to do this is throw it on your graphing calculator. Put this one in red on your graphing calculator, put this one in green on your graphing calculator, and make sure that they're one on top of the other. So let's do that right now. Notice what I did right off the bat. I'm in radians. Yay! Okay, so being that I'm in radians, I should just be able to put the calculator up there, put the values in. So let's just type it all in there. Okay, minus 75. Then here comes your cosine, okay, of pi over 16. So I'm going to put that as a fraction, okay, pi over 16. Beautiful. Get out of there. Put a bracket around this. That's going to be my x right there. Boom. Don't forget to close off the bracket. You can even see it. Plus 90. All right. Perfect. And now I'm going to put my other guy in here. My other guy, of course, we know was 75, but now it's a positive 75 cos. I still have my pi over 16 still there because my period hasn't changed. Just because I shifted my graph back and forth, I haven't changed my period. There's the 16, okay? There's my bracket, but the shift now has to come in here. There's my x minus 16 because I moved it over 16 minutes, right? Bracket, and then there's my plus 90. Now, before I hit graph, you got to make sure that your windows are set up properly. So let's go back to here and figure out our windows. Well, you know our windows. Look, it's right here. This is why we sketched this graph out first. Our windows are going to be from about 0 to 165, okay, up to 32 minutes. Okay, so let's go from 0 to 165, that's our y, and from 0 to 32 minutes, our x. 0 to 32 minutes, and from 0 to 165. Oh, hold on, there we go. From 0 to 165. There it is, perfect. Okay, graph it. Now, if I graph this, watch what happens. There's my original graph, and there's my red graph over top of it. So whether you're talking about the positive version of this or the negative version, you get exactly the same graph. That's what's really, really cool about this. Now, let's go back to our question here and finish this off. Okay, so the question says, where are you on this ride if you're 20 minutes into the ride? Okay? What if you're 20 minutes into the ride? Where are you on this? Think about that. Isn't 20 minutes time? So aren't you in fact finding h as a function of time? 20 minutes. And it doesn't matter what graph you put this in. You just put it in there. Look, I'll use the positive one. Isn't this 75 cos pi over 16, right? This would be now 20 minus 16 plus 90. There you go. There's your value of time. So if you put this into your calculator, oh, this is really, really easy to figure out. Okay, here we go. Calculator time, right? Second quit. All right, here we go. So there's my 75, right? Cos. I can put in my fraction of pi over 16. Beautiful. This is going to be now, remember your x value was at 20 minutes. So let's put in 20 minutes. 20 minutes minus the 16 that was in there because I'm using the positive version. Don't forget your bracket, which finishes it off, plus 90. According to this, you're at 143 meters above the ground. Scary. But you know what? This is what I don't like about calculations like this. It's a number. You know and I know this is at 143 meters. Yippee skippy, who cares, right? Oh, and it's to 1/10 of a meter. Oh, 0.0, okay? 143.0. So yippee skippy, that tells me I'm at 143 meters. But honestly, I don't know where that is. Look, go back to your graph. Put in the value, second calc value. You know that you want to figure out what the time is, where the height is at a time of 20 minutes. Punch it. Look, it tells you you've already gone through the graph, hit the max, and you're on your way down here. And look at that. Bada boom, bada boom. Okay? It tells you there's your 143 meters. I think doing this graphically rather than algebraically makes a heck of a lot more sense. Don't you?